Okay, so let's look at another example of using these kinematic equations in one dimension. And this one is a slightly more complex problem, and we'll look at why here in a second. It says a car accelerates at a constant 6 meters per second squared. The car starts from rest and moves for 10 seconds. What is the average velocity of the car? So just like I did in the last video, let us write down all the variables. X naught. It's not given to us, and again, you pretty much just assume it's 0, your starting distance. So it's 0 meters. Your final distance, your final X, they didn't give us at all. They didn't tell us anything, just nothing there. So if I want to, I can just kind of put the line through that one. My initial velocity, it says the car starts from rest, so that's 0 meters per second. My final velocity, they didn't give us that at all. Acceleration, that was 6 meters per second squared. And the time is 10 seconds. Okay, now the question is, what are they asking for? They're asking for average velocity. And what is the equation for average velocity? Well, average velocity is V naught plus VF divided by 2. That flies back. Another way of writing that sometimes could be 1/2 times the quantity V naught plus VF. Because it's average. Average, again, average is when you add everything up and divide by however many things there are. So here's the problem though. I have V naught, that's 0. I don't have VF. I don't have the final velocity. But the question is, can I find it with the information I have? Sure you can. Just say to yourself, what equation does not have X in it at all? And again, you should know that by now. You should know these 5 main equations. And the one you need that does not have X at all, or distance I should say, because when X, it could be Y if it's vertical, is this one. VF equals V naught plus AT. And again, if anything is a 0, go ahead and cross it out. So that's 0, V naught 0. So that says VF equals acceleration times time. Do I have acceleration in time? Yes, I do. Acceleration is 6 times time, which is 10. 6 times 10 is 60 meters per second. So my VF is 60. Now that I have VF and I have V naught, I can easily find the average velocity. Again, average velocity, I wrote it above, is V naught, which is 0, plus VF, which is 60, divided by 2. So, you can do this in your head. 0 plus 60 divided by 2. Your average velocity is 30 meters per second. 6 is 1 sig fig, 10 is 1 sig fig, 30 is 1 sig fig. So it works out. And there you go. Now, what's really cool is there is a totally different way of solving this problem and getting the exact same answer. And anyone who can do that, bring in your work, show it to me, and I will give you extra credit. But I'm only going to do it to the very first person who turns it in. That way you guys can't swap it and share it between each other. So again, bring it in. Or if you want to, you can work together on this one, but I have to divide up the bonus points between however many people worked on it together. But again, bring this in, show me how you do it another totally different way and get the exact same answer, and I'll give you extra credit. Because that's what I love about physics. And Charlie Durbin, back when he took this class, he and I would totally come up with all sorts of different ways getting the exact same answer, the exact same solution. But we did it totally different methods using different equations. Because that's the beauty of physics, is as we go along, the more equations we get, the more variety of ways there are to solve problems. So there you go. This is done lesson.